I'm going to explain why I've drawn such complex boxes there. Let's draw a sample of the box down here, and it's got 9 cells in it. This is one that I find particularly practical and useful, as do many. I'm going to put the description in here, okay, like that. We could also call that an activity number if we wanted to. We could put that somewhere else. And in this place here, this cell, we're going to put the early start. And we'll put the early finish for that job, and we'll put in here the duration. I'm going to measure the duration of these jobs in time units. I'm not going to tell you what those time units are at this moment in time. We're just going to call them time units. We'll abstract ourselves on this, and we'll have very simple maths to go with this. So, how do we know the early finish from that job? Well, very simply, I'll draw it up here. Our early finish of any job equals the early start plus the duration. I'm going to do a couple more equations here, so I'm going to call that, surprisingly enough, equation 1. And that simply gives me this early finish from a job. And we're going to use a critical path analysis eventually. That's going to tell us the fastest or quickest time we can do this job, this complex project. I'm going to make the assumption that we start at a time called 0. You may say, what is time 0? I'm going to say it's a special case before any of the time running on this job has run. It's just before we start time period 1. So there we have time period 0, or time 0, and our first job, A, let's say it takes 5 units. I'm going to go through and put some units on each of these jobs. I'm going to say this takes 10 units, this takes 7 units, and this takes 8 units there. And we'll probably run with 12 units here, 7 in here, and 11 over here, and we'll do 12 here. And this last job here, we'll say 9. We want to know how long it takes us to do this whole project. And for that, we're going to do what is known as a forward pass. We're going to find out the earliest possible time we can do this job. And so I'm going to track you through that in this first session. So the earliest finish of activity A is simply the early start plus the duration. Early start plus the duration. 0 plus 5 is 5. Now, that's the end of period 5. And we now need to know what's the earliest possible time we can start activities B, C, and D. Well, by the same reasoning we used for time 0, we're going to say we can start B absolutely a tiny period before the end of period 5. So we're going to say that starts at period 5, period 5, period 5. We're not worrying about anything other than these pure time units. And that gives us the ability to move on using that equation to show that the early finish for activity B is 5 plus 10, 15. For C, it's 5 plus 7, 12. And for D, it's 5 plus 8, which would be 13. Okay? So we're tracking through on what's known as the forward pass, trying to find out how quickly we can do this job. And in order to look on as where we're going, we say, well, what's the earliest time we can do activity E? Well, there's 2 choices there, because it looks like we could start it by the same reasoning as before, time period 15, or from D, where the late finish moves up to become the early start of E, it could be 13. So it could be the early finish of B or the early finish of D. Very simply, we have to choose between those. Now, since we've said that we have to have B and D done before we can start E, then quite clearly we can't start E while B is still operating. So we have to have finished D and B in order to get job E started. So we must take the maximum of that choice there. That's the maximum, so we'll put that 15 in here. So 15 plus the duration, 12 for E, gives us 27 for the early finish of E. Simply looking at activity F, there's only one activity driving that, that's C. So that early start is 12, giving us an early finish of 12 plus 7, 19. We can move on to some other activities here, and I suggest that we do the calculation for G, which says now we have to have F done before we can do G. So that gives us the early finish of F, 19, is the early start of G. That gives us an early finish of 30. And if we look at E, influencing or being a predecessor for activity H, then early finish of E is 27. That becomes the early start in this simplistic method for H of 27. So 27 and 12, giving us an early finish of 39 for activity H. Now, the start of activity J is constrained by three activities, F, G, and H. So that means our choices there are 19, the late finish of F, 30, the late finish of G, or 39, the late finish of H. And that example that we used earlier was when we had a choice, we took the maximum. And that's actually a consistent way of operating all the way through. Whenever we're doing the forward pass, we're trying to find out what is the shortest possible time we can do this work in. We always take the maximum whenever we've got a choice in this forward pass rule. So we've made the choice from those three predecessors to the start of J, which were F and G and H, and we chose between those late finishes of 19, 30, and 39, and we end up with the maximum, 39, so that's our early start for activity J, giving an early finish of activity J of 39 plus 9, which is 48. That early finish, clearly there's only one activity that ends this network in this job. That's the early finish of the project, and that's the earliest time we can complete that project. It's actually the project duration, and it's the fastest time we can do it.